I'm always trying to understand free energy application of concepts, and in particular, how might it apply to Barbosa and Leal. So I'm over here at free-energy-info.co.uk/energymachines.pdf, and energy and machines are both capitalized. It's a PDF file, and it's a Chinese guy, and he's talking about, he's obviously using the rhetoric of intellect to try to convince people that what he did is not only possible, but is applicable or possible in many different ways. And in fact, his cohorts came up with various methods of creating free energy. And they did a little experiment, and it's a very interesting, more than a demonstration or explanation, embodiment. An embodiment of the concept of what he's trying to present. And I noticed in another person's paper, I don't think it was this one, they talked about work. Everybody talks about conservation of energy, but they never talk about conservation of work. And of course, work has to do with the whole idea of free energy, and COP over unity is how much work do you have to do to move that boulder, as with your bare, brute force of your hands alone, or kicking the boulder if you like, versus getting a smaller little rock or boulder, putting it up alongside it, and getting a long stick and use the principle of the lever. Well, no energy has been created or destroyed yet. The work you're doing is far less, and you're actually moving the boulder on top of that, all by yourself instead of with 10 guys to help you. And so that never fails to amuse me, how much we take apart things from a scientific perspective, but we forget what it really is in real life to get things done, the easy way or the hard way. And that's what matters. So he's got this demonstration, and it's basically a column, a tubular column to fill a tank at the top with water, using a tank of water at the bottom that drops its load into the receiving tube before it does an L turn and goes upwards. And there are one-way valves everywhere. There's a one-way valve at the base of the inlet tank, and there are one-way valves all the way up the well, I'll just show you. What am I doing here? Alright, there you go. So there's your device. And number 2 is a pump. It's an air pump. And the water in tank number 4 is a mixture of both water and air. And then it gets sent up, and you measure how much energy it took. And then you start to wonder, well, gee, this is weird. Why? Because you were pumping a mixture of mass in which not all the mass had the same density, yet the amount of work you did was the same, because the volume is the same regardless of how much of that volume percentage is air and how much is water. You can change it, yet the work is the same, because it's the volume that the pump has to move, per unit of energy that the pump works at. It's still the same. And so you could literally lose energy based on how much air bubbles you mix with that water, because you drop the water, and gravity, it's gonna be that dropping water. If you have water dropping on a water wheel, it's going to make a difference whether there's less water or more water, because the balance of air bubbled out of solution and left and went up to the sky, and you don't have it to move your water wheel coming down the mountain, because you moved up a volume of mixed water and air up the mountain to get to that top of the mountain, come down and move your water wheel and grind your corn. So it's a very interesting concept that you can literally force yourself to create under unity by varying the mixture of water and air. The volume's the same, but the density is different. yet it still costs you the same amount of energy to pump it up an incline. Well, that's like, hey, heck, anybody could have known that. You drive a car up a hill versus driving it up the hill full of passengers, towing a load behind it. No, excuse me, not towing a load behind it. No, just putting lead weights inside, buckled up with each seatbelt, even heavier than people, and now you've got a heavier car. Yet it's the same volume on the interior of the car that you're moving up the hill. It's the same volume. The glass is half full or half empty, or maybe it's fully full, or maybe it's completely empty or nearly so. Yet you still have to move it up the hill. It's a bad analogy, sorry. Because here we're dealing with volumes. We're not dealing with mass alone. See, the pump is at the base, and the pump can only pump a certain volume per movement of its impeller or propeller, whatever it's using. And that's irrespective of gravity. So, yeah, let's just stick with... Actually, this would be a better model if it had no incline, if you didn't have to go upwards. If you just went on a horizontal. Just going on a horizontal, it still works out. The demonstration of the principle is still the same. So, it's a very good concept, and it means, let's now apply it to electrical energy. We've got some amperage flowing, and it doesn't matter whether the amperage has high voltage or low voltage, it's still the same amount of amperage. The amperage represents the volume of water, and the voltage is its density. Is it air, or steam, versus is it water? It's a big difference, yet it's still the same volume. And I think that's what Barbosa and Lille have managed to do. They take a certain volume of amperage that's flowing around inside that electric keeper, and they apply voltage to it from the earth, from the grounding rods, let's say, planted in the earth. Let's keep it simple. And that variable voltage applied to that keeper, that electric keeper, the continuous loop, makes all the difference as to whether or not that energy is greater or less, even though it's the same amperage. So we are reusing the amperage of the electric keeper. It is being recycled. And yet that's not the big deal alone. It gets better because now it's a variable. You can vary the voltage regardless of the fixed amount of amperage that 4-gauge wire is capable of moving around inside itself. There's a limit, but there's no limit on the voltage that pumps it along. There's no limit. And that voltage is going to be demonstrated, or exhibited, I should say, by the density of the amperage at the output. But because we can't run our machines on anything other than a regulated voltage, we have to have that shunt between, this is not the whole schematic obviously, it's just focusing in on the central portion, the shunt between the electric keeper and the top wire that supplies the load. Actually, it goes off the graph, off the picture here, but it goes to the load. And that's coming out of plug number 1 of the pure sine wave inverter. It's the hot lead. But the neutral of that plug number 1 is broken. It's broken between the two sets of grounding rods down at the bottom here. So it never has current of its own to send anywhere. It never has a closed circuit. And even the neon bulb doesn't exactly make a complete circuit, because the neon bulb comes from plug number 2. And the neon bulb doesn't pass any amperage once its strike voltage gets it going, of 90 volts, gets it going. So all we have is the Captor loop, right in here, the Captor loop driving from the electric keeper, driving, or imparting, I should say, a sense of amperage to the voltage coming from the grounding rods, because the grounding rods themselves don't have any amperage of themselves. But the electric keeper has it. So it's a specialization in which we've got the amperage within the electric keeper and we've got the voltage within the rods, and we combine it in this very peculiar way to power the load off the screen. And the shunt there keeps the voltage regulated. So if the voltage has to be forced downwards, oh dear, excuse me, no. It's both. It's a blend. It's forcing the voltage of the electric keeper upwards. Yet the sine wave inverter is going to want to make sure the voltage stays the same. So the magic of converting that excess voltage downwards into amperage happens within and among the two toroids. And it's the case of diminishing returns. Every time half of the voltage gets turned into amperage, there's half less to have to turn into amperage. And so it happens suddenly at first, and then it gradually diminishes, kind of like a hyperbolic curve. If you chart out the conversion of the excess voltage into excess amperage, it's going to be sudden at first and then slow down its alteration over time until it seemingly comes to equalization, but never actually does, because you keep having your voltage by turning half of it into amperage. So you never convert all of it at any specific time. You always have a slight excess, but it'll be close enough to what the load requires off screen there to do the job. Or else the excess voltage doesn't get to be used, and it stays in the rods, keeping them charged up, such as they are, functioning as a capacitor planted in the earth, a ferroelectric capacitor. So there are obviously some various components of the system that operate very interestingly, and this is just one of them. Not to say there aren't some others, because then we've got the grounding rods themselves acting as a fishnet, so to speak, because they create an electrostatic field to catch the magnetic field of the earth and harness that into added electrostatic charge. So the device, the circuitry, charges up the grounding rods with electrostatic force, but they collect magnetic force that gets converted into electrostatic force. So there's no competition. None of the circuitry competes with itself in any way, shape, or form. It does not compete with itself. That's the neat, nifty part of the circuit. There's the load off to the right there. There's nothing at all. And of course, concerning the strike voltage, there's that link. You can put an underscore between the two words of neon bulb to get the original, but joined together it gives you an archival version of what Clarence has to say about the operation of this neon bulb, how it functions, how it does its job. And interestingly enough, the neon bulb and resistor pair kind of act like a diode. And it does matter which way it's oriented, which side the resistor is on. I hope I have it oriented correctly. Because it wants to put in its initial strike, when it first turns on and has at 90 volts strike voltage, it sends it over to the line or the grounding wire that comes from the captor loop, and sends it both ways, up to the electric keeper and down to the grounding rods. It's 90 volts strike voltage, but then it quickly tapers down to 0.2 volts and does not allow any amperage to flow through it, which means the voltage all backs up on this side of the neon bulb, probably because that resistor is there. So the resistor is there not only to protect the system from any kind of lightning strike in the earth nearby, but it also prevents anything from coming in, well, because it's acting like a diode at that point. It's actually a two-way diode, though. Yeah, that's true. Okay, sorry. A two-way diode, whatever. Anyway, I'm making too much of that. So, yeah, that's off topic. So the main thing was it had to do with starting out with the electric keeper, and then also I got into another, see, that's how it was. I did a sidebar with the grounding rods and the electrostatic field. So the main idea is this idea that volume is everything. And because that'll determine the efficiency of your work. You know, are you expending, how much energy are you expending to perform the amount of work that you're doing based on the density of the volume or mass, the density of the mass of energy or the mass of material that you're working with. How efficient is your system running at? You know, if you're carrying 10 pounds of money, it sure would be nice if each note was a $100 note as opposed to a dollar note, because you still are limited by how much weight of money you get to carry, because it's just you. And so the leverage is the little number on each piece of paper. Makes all the difference. It may seem like a wimpy analogy, but it's very similar to this situation. So I find it very intriguing what he's talking about. Very intriguing indeed. Now he's saying that energy comes from air. Right here. I thought that was energy in the form of added work, but when you think about it, when it's under pressure, bubbles shrink. That's right. And when it's elevated pressure, or excuse me, elevated altitude and reduced pressure, the air bubbles will expand, so the volume increases once the whole system depressurizes the air-water mixture, which is an advantage too in its own way. So there are different things of looking, different situations of looking. I guess that's what they were looking at, was the expansion of air is added bonus. I didn't think of that. Different way to explain it. So actually it's gaining, the output is greater than the input because the volume is greater. When it gets up to the top and the air has a chance to expand. I see what he's saying. That's interesting. So that means that when the voltage is diminished, and converted into amperage, it's more than just a conversion. Your watts goes up. In other words, you're allowed to add watts to the system. And that's because, you know why? Because the conservation law of energy deals with each plug separately, the input separately. And then we've got the input from the earth, which is the third input. It's like a third plug. Each one is separate, so the conservation law only applies to each input line. Yet they get mixed. And this is what the fellow was talking about when he was talking about ferroelectric capacitors. It's the mixing of energy from different sources. If you've got voltage from one source and amperage from a second source and you mix them, you can actually end up with more energy than you had before you started. And that's what this fellow talking about the water and the air mixture is saying the same thing. So this device is a mixer, an energy mixer. That makes sense to call it that way. Well, why is it more watts? Well, energy in, it does equal energy out. But you're getting it from 3 different sources, 2 from the sine wave inverter and 1 from the earth. So you really are harvesting energy from the earth. So it might be correct to say that the amperage flowing in the electric keeper is an oscillating energy because it keeps recycling, but that's not the beauty of the system. The beauty of the system is that it's an energy mixer, such that you are allowed to input a free source of energy from the earth that you don't have to pay for, except by a little bit of payment coming from plug number 1 and a little bit of contribution from plug number 2. But you're creating a fishnet of energy among the grounding rods to collect energy from the earth and bring it in. You're harvesting energy. You're not creating energy. So that's where the law of conservation breaks down, because it only has to do with creation and destruction of energy. It says nothing about harvesting energy from outside a system to bring it into the system to add to the energy that's already in the system. So you see, that's where these things break down. The laws of physics don't say anything about harvesting energy. They don't say anything at all about harvesting energy, using energy to harvest energy. It's an uncanny concept, but the laws of physics don't even apply. They don't even address the situation. They're silent on the situation. They're totally silent. They're totally silent. And that's the proper way to look at Stanley Meyer's water-fueled dune buggy. It's harvesting energy from the air by collecting it, breaking down the nitrogen, turning it into ammonia, and then burning the ammonia ignited by the hydrogen. It just went and not only collected, but it processed, most importantly, and that's what this does. It collects and processes. That's what the mixing entails, a processing. So it's a combination of harvesting and processing, which gives you that added energy and doesn't break any law of physics. But it's beyond physicists and electrical engineers to think that energy could be used to harvest energy. Well, I don't know. A windmill uses... Doesn't it use energy to harvest energy? No. See, the problem is they use matter to harvest energy. No, that's not true. No, well, let's see. Yeah, they're using passive energy. See, they're not accustomed to using active energy to harvest. Oh my goodness. Oh my God, they turned the tables. We're accustomed to thinking that we have to use passive energy to harvest active energy. And thus, you never include the passive energy in the equation. You just include the inrush of active energy, let's say the wind blowing across a stationary propeller blade of a windmill. And then they only credit the energy coming into the system from the wind, and they never credit the passive energy of the ability of that windmill to turn, because it's just sitting there at rest. But that's, what do you call it, potential energy. You have to figure that into the equation. Even though the propeller blade starts out at a state of rest, it has potential energy based on the mass of the propeller blade and its ability to turn the generator. It's only when the two mesh that you actually get an output that's greater than the input, because they didn't figure in the passive component. So they didn't even do their energy equation correctly, and yet they'll say that this is a perpetual motion machine, namely that it cannot be explained by the laws of physics, because they refuse to do their energy equation correctly. They refuse to do their math correctly, their accounting. It really is a we have ourselves a class-oriented society in which certain things are excluded from our class, from our structure, from our social structure. It's amazing. We excluded the blacks when they were slaves. We excluded the Native Americans before they got drunk or got shoved onto Indian reservations or got killed. It's amazing how we can exclude things by way of denial just because we choose to, just because we want to. Voluntary denial and dismissal. Very interesting. Wow.